typing this code in over here as I see it. So let's write that down. And what are we going to get? Integrate. And what are we integrating over here? It looks like the square root of x, and with respect to x, and we're starting at 1 and stopping at 4. What's that, 14/3? I'm going to approximate that. Use the underscore dot n. That dot n is an abbreviation for numerical approximation, and that's about 4.6. Keep repeating it. Let's do the next integration. Integrate. What are we integrating? Square root sqrt. This case can be x plus 1. It's an equivalent integral, by the way, x, and we're starting at 0 and stopping at 3. What do you get over there? 14/3. And again, if you do the numerical approximation on that, what are you going to get? And the same thing, 4.6 repeats forever. Let's do the sum. And this where, I was kind of concerned about this, that Sage wasn't able to do the sum. All right? So I still want to put it down, by the way. So Sn. And this may be due to my ignorance, by the way, why Sage can't do that. Maybe I don't know really how to use Sage properly. And what's that going to be? 3 divided by n star integrate. Square root sqrt. And that's going to be 1 plus 3 star I. Let's see, divide by n. Let's see if I did that. Yeah, I think I did okay. The counter is going to be I. I is going to be starting at 1, and it's going to go off to n. That's what Sn is. All right? So what I try to do is, the same thing, limit. And what I noticed is it spit back something that really wasn't expecting to say, or it's not doing it. All right. So what I want to do is go back and talk about approximating it. So I'm going to do S of, let's just do 10. I'm going to approximate it, because if I do S of 10, it's going to return this over here, and I don't want that. I want an approximation to that. So let's write this down, S of 10. And let's see, whoops, sorry about that. And I'm getting this number over here. And that's, it goes 1 up to 10. 1, 2, 3, 10 terms, by the way. And, it's not that number there. Let me do a bigger number now. Let me do 1,000. And now I'm getting 4.67, all right? Now, granted, it appears to be converging quite slowly to what it should be. Like if you went to 10,000, let me do that. It's going to take longer to do that, by the way. It's 10,000 terms it's computing. What is it doing each time? It's doing quite a few computations, by the way. And really, it's really, in my opinion, thuggishly doing those things because it can't figure out the sum. All right. As it's working that, though, I want to go to Wolfram Alpha. All right. And in Wolfram Alpha, what I'm going to do is I'm actually going to copy. And I'm going to go to Wolfram Alpha on the website. Let me see if I can do that. Let's take a look at here. Wolfram Alpha. Let's see. I'll type that in. Hit return. And I'm kind of curious if that can do it. It gives me some interesting things over here. Not what I want. I'm going to do limit now. The limit of this as n goes to infinity. Let's see what happens. Let's see if it understands me. It says, continuous limit discrete instead. I'm going to have to go there. But you know what it's doing is get 14/3. All right, 14/3. Am I expecting that? I'm expecting 14/3. So what's take-home message over here? Sage is still trying to do that computation. I'm going to quit it. So Command C, and let me clear, because a lot of nonsense on the screen right now. All right, so let's go back over that. That number appeared to be too big for it. Do 1,000. It still has to. It takes some time to do it. About 4.67. It's doing fine. What's the advantage of using something like Wolfram Alpha? It's costly software, by the way. You're not really getting anything for free, by the way. Sage is open source. Um, Sometimes I will say this though, Sage in a large number of cases is actually faster than the Wolfram product. It's really one of the fastest things over there. Now, granted, at this level here, I'm not sure if I'm using Sage correctly or not. Maybe it's my fault in not being able to code this thing correctly. All right, thank you.